Hello and welcome everyone. My name is Dane Menke. I am the Digital Marketing Manager here at Regenesis and Land Science. Before we get started with the webinar today, I have just a couple of administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we do not address your question, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's webinar will discuss a case study outlining the largest residential vapor intrusion investigation in California at the site of a former aerospace manufacturer. With that, I'd like to introduce our presenters for today. We are pleased to have with us today Jessica Law, engineering geologist and case manager for the Santa Ana Regional Water Quality Control Board. She has worked in the environmental field for 16 years on various leaking underground storage tank and site cleanup sites throughout California, overseeing assessment and remediation activities. For the first 12 years of her career, she worked as a consultant, managing sites through various stages of the project lifecycle. In her current role with the Santa Ana Regional Water Quality Control Board site cleanup program, she oversees a variety of cases, including former industrial and former dry cleaning facilities. We're also pleased to have with us today Thomas Szocinski, Director of Vapor Intrusion at Land Science. Tom is a nationally recognized vapor intrusion expert with over 18 years experience as an environmental scientist, focusing on vapor intrusion assessment and mitigation, remediation, site assessment, and brownfield site management. He has served on both state and federal regulatory vapor intrusion review boards, assisting with development of vapor intrusion and mitigation guidance, regulations, and exposure criteria. All right, that concludes our introduction. So now I will hand things over to Jessica Law to get us started.
Thank you, Dane. Hello, today I'm going to talk about a successful large-scale vapor intrusion investigation and provide you with a regulatory perspective. This is currently the largest residential vapor intrusion investigation in California, and this investigation has followed many key principles that are laid out in the draft supplemental vapor intrusion guidance. Also, data collected from this project is being utilized in 2 of the 3 attenuation factor studies. So today's presentation will include a brief discussion of the project history to provide you with some project background. Then I'll move into the vapor intrusion investigation and finally discuss the key components for the ongoing successful investigation. This site is located in Southern California in Orange County in the city of Newport Beach, which is outlined here in black. The site is located approximately 2 miles from the Pacific Ocean, and there are creeks to the north and south of the site that do flow to the upper Newport Bay. This site is a former aerospace and electronics research and development facility that operated from 1957 until 1993 on 98 acres. The facility was divided into 2 distinct areas. The main area located here, which was approximately 90 acres, and then the aerothermal chemical building area, referred to as the ATC area, located in the southern portion down here, operated on approximately 8 acres. Assessment activities began in 1990, and the facility was closed in 1993, which is when the demolition and remediation activities of the facility began. The contaminants of concern for this site are volatile organic compounds, primarily trichloroethene and tetrachloroethylene. The hydrology in the area is fairly complex. There are several buried arroyos which groundwater tends to follow, and most are identified on this figure here. Now, groundwater leaves the site in 2 directions. From the main area, groundwater flows towards the north and follows this buried arroyo here. And then from the ATC area, it flows towards the south and follows this buried arroyo here. And this has resulted in 2 off-site areas of investigation interest. The general vicinity of the site is elaborate. It consists of single-family residences, condos, townhomes, apartments, shopping centers, churches, which include schools. There's other commercial properties, a golf course to the south, bike paths, and there are those creeks that do lead to the upper Newport Bay. Groundwater and surface water are also being investigated, but for the purpose of this presentation today, I am only going to talk about vapor intrusion. So some of the key dates for this project. In 1996, based on information provided by the responsible party, the regional board determined that remediation of the main area was complete, and in 1997, the LOP granted soil closure, which allowed the property to be rezoned for residential and was redeveloped, which began in 1998. There was the requirement, however, for continued off-site groundwater assessment and remediation, and the case was transferred to the regional board for regulatory oversight. Now, since that time, all work has been conducted by the responsible party under a voluntary agreement. From 2001 through 2004, there was remediation in the southern off-site area that was conducted to address impacted groundwater down gradient of that ATC source area. And then in 2006, 2008, and 2012, there were limited soil gas assessments that were conducted, and those concluded that health risks from vapor intrusion were not present. Now, these conclusions were made without any indoor air samples being collected. And those conclusions were also prior to the 2014 US EPA memo regarding acute TCE exposure and the updated 2016 San Francisco Bay Regional Water Quality Control Board environmental screening levels, or ESLs, that we utilize. In 2017, a conceptual site model was prepared and submitted for this project. And the CSM, it looked at all of the site history and all of the data that had been collected, and it compared it to the current screening levels, and it identified potential data gaps that would require additional investigation. One of those data gaps that was identified was the need to reevaluate the site for potential vapor intrusion risk due to groundwater concentrations and those previously mentioned historical soil gas assessments. And then in 2018, that is when the vapor intrusion assessment began. So for the vapor intrusion investigation, that began with the approval of the initial soil gas work plan in January of 2018. The work plan proposed the installation of 14 soil gas probes, which were installed in May 2018 and sampled the following month in June. Based on those results, indoor air sampling was going to be necessary. In July of 2018, the indoor air sampling work plan was submitted and approved. And this work plan included a decision flowchart, which established a clear path forward for the entire vapor intrusion investigation. So decision flowcharts were prepared for residential and commercial properties as part of that initial indoor air sampling work plan. Since TCE has short-term exposure risks, this allowed the investigation to continually move forward without requiring additional work plans for next steps. They were already anticipated and laid out. And this allowed for simple addendums to be submitted for our approval when additional soil gas probes needed to be installed for further delineation, or additional homes were to be included in the investigation. And there were 3 main paths that were anticipated to be conducted. One, the installation and sampling of soil gas probes. The second, determining buildings for indoor air sampling based on soil gas results. And then the third was sampling indoor air. but access played a crucial part initially with keeping all of these wheels spinning. There are 3 commercial properties and 11 homeowner association communities which required access agreements to install soil gas probes even on the streets within those communities. And many communities did delay providing access out of concern for things like property value or how this would make their community look out of liability, fear that they would be responsible if something was found, and so on. Now, this is what the decision flow charts looked like within the work plan. So the following groups were broken down into those initial steps regarding the soil gas assessment, which included delineating the soil gas plume to non-detect. And this section outlines the next steps based on the soil gas results, prioritizing homes that should be evaluated first based on short-term exposure risks. And then this area outlined the next steps based on indoor air results, which also included timeframes for when the next steps should occur. And the flow charts were based on the current vapor intrusion guidance documents, the 2016 ESLs, and the US EPA TCE action levels. So now we're going to transition to the vapor intrusion investigation portion of this presentation, but first just want to provide a brief overview of vapor intrusion. As you know, vapor intrusion is the migration of vapors in the subsurface into a building. So here is just a simple vapor intrusion conceptual model to show a source, whether it's in the soil or dissolved in groundwater, and how soil gas can migrate in the subsurface and potentially enter a building through cracks in the foundations or utilities that enter the building. Now, for this site, the primary contaminants of concern, as I mentioned, are TCE and PCE. Weather conditions such as barometric pressure, wind, and temperature, as well as the use of heating and air conditioning, can affect vapor intrusion, which is why, regardless of results, samples are being collected during both winter and summer seasons. Now, groundwater concentrations can be used to evaluate the potential for vapor intrusion to occur, but the preferred sampling method is collecting soil gas samples. And soil gas samples should be collected from multiple depths. 15 feet below the foundation of the building if you have deeper groundwater, and no shallower than 5 feet below ground surface. And those sampling depths are for evaluating the building for potential vapor intrusion. Deeper soil gas sampling is still necessary for evaluating the extent of the soil gas plume if groundwater is deeper. For this site, since there's no basements, the soil gas probes are installed at 5 and 15 feet below the ground surface. And regardless of the depth, the highest soil gas concentrations are considered when evaluating a building for potential vapor intrusion. Soil gas samples are analyzed for all VOCs. Indoor air samples are collected over a 24-hour period from various rooms and analyzed for select VOCs. And the work is being conducted in accordance with the current vapor intrusion guidance documents. So here is a very detailed project timeline since the vapor intrusion assessment began. Bear with me and I'll kind of cover many aspects of this. So as I mentioned, the work plan was first approved in January 2018, and the first initial soil gas probes were installed in May 2018, with them being sampled that following month in June. The first indoor air samples were collected in July from a commercial building, and the first residential samples were collected in August 2018. Now, some of the number totals for this project since the investigation began through December 31st, 2019. 549 homes have been offered indoor air sampling, and there are 298 executed access agreements. At least 281 homes have been sampled at least one time, and there are 3 commercial properties that have been sampled at least once. There are 311 soil gas sampling locations. And as I mentioned, each sampling location has a soil gas probe at 5 and 15 feet, with the exception of a couple areas where there is shallower groundwater and they couldn't get a deeper soil gas probe installed. You'll also see that there's two references, a SG, which refers to soil gas. Those are the soil gas locations for delineating and evaluating the entire soil gas plume. And then there's what's referred to as parcel PSG, or perimeter soil gas probes. And those are soil gas probes that have been placed around buildings for buildings that cannot have subslab soil gas probes placed inside them for various reasons. And then there have also been over 1,300 soil gas samples collected over the last year and a half of this investigation. Now, throughout the assessment, the current path forward is constantly being reevaluated to ensure it is still the most appropriate. We all know vapor intrusion standards are ever evolving. Therefore, sewer gas sampling was added for select areas during the third quarter of 2019 as an extra line of evidence due to a few homes where there were exceedances in indoor air, but not in the subslab, and there was no obvious indoor air source that was identified. Therefore, prior to concluding it was not from vapor intrusion, sewer gas samples were collected to support this. Also, due to the length of the investigation, assessment progress reports are being submitted quarterly. Now, here is a detailed site figure for the vapor intrusion investigation, and I will be zooming into a few select areas in the next couple of slides. But first, I would like to just provide you with a general overview. As I mentioned, the former facility, which is located here, consisted of 98 acres, and there were those buried arroyos that are highlighted here that I had mentioned earlier. The vapor intrusion assessment began in 2018 with the installation of 14 soil gas probes that were placed based on the potential for groundwater concentrations to off-gas and become a potential risk for vapor intrusion, and then to reevaluate the previous soil gas sampling results. Now, based on the soil gas results, additional phases have been conducted to step out until the soil gas plume is fully delineated to non-detect. The soil gas probes are monitored on a semi-annual basis. Contour lines are based on the 2016 ESLs that would trigger indoor air sampling, as well as the contour line for TCE that triggers the need to expedite indoor air sampling. The shaded areas on this figure represent properties where buildings should be evaluated for vapor intrusion based on soil gas ESL exceedances. The blue shading is for commercial properties, and that green shading are residential properties. Now, if an area has been shaded, it will not be unshaded based on future results, meaning offers to the public for indoor air sampling will not be rescinded. And then the plume length from about here to here is a little over 1.5 miles in length, and then it's about 0.5 mile wide right here. Concentrations have been presented in micrograms per cubic meter for this project, and all of those pink squares on this figure are the existing soil gas probes that are used to evaluate the plume. And the probes are placed to evaluate the potential for preferential pathways such as those buried arroyos. So now I'm going to zoom in a little bit to a few select areas of the plume. There is additional probes on this figure that were not on that primary figure that I showed on the previous slide. And those are those perimeter soil gas probes that I had mentioned. Again, due to various reasons, some communities like this one could not have subslab soil gas probes installed. So these probes are placed around the building to evaluate indoor air samples too. And the higher density of these soil gas probes have shown that at the plume edges, preferential pathways do play a significant role in the migration of the soil gas plume. And again, here's another example of the soil gas plume having a small portion migrate away from the plume edge. Now, based on the known hydrology, groundwater did not flow this direction. Yet the soil gas plume has migrated east between these two buried arroyos. And this just, again, reinforces the need and the importance of delineating to non-detect and properly placing the soil gas probes, in this case, both near buried arroyos and between them, and not making any assumptions for how one may think this soil gas plume will behave, needing to have that data to support any assumptions. And then here is the southern portion of the vapor intrusion investigation area. Here is that southern ATC area from the former facility on this figure here. The initial soil gas probes were located along this buried arroyo here to evaluate for vapor intrusion from the southern groundwater plume. And the results from those initial soil gas probes for the contaminants of concern were below the ESLs, but they were not delineated to non-detect. And so a second round of step-out soil gas probes were installed, and most of them had non-detect results. But there was one probe that had a detection of almost 18,000 micrograms per cubic meter of TCE, suggesting there was an unidentified preferential pathway. So additional step-out locations did delineate this plume, and again, it reinforced the importance of delineating to non-detect. And then these two communities both have buildings here and over here that have multiple units sharing a foundation. Therefore, if a contour line crosses over a portion of the foundation, all of the units are offered indoor air sampling. The final portion of this presentation will discuss what I believe are the three components for the successful ongoing investigation, which includes the following. Collaborative communication is key, especially with both the responsible party and the consultant. This allows for quality technical discussions so that the project objectives are met throughout the project. I mentioned those decision flow charts earlier. There was a lot of great communication between the water board, consultant, and responsible party prior to the work being submitted to ensure that those submitted decision flow charts established a clear path forward for the investigation. Public outreach and providing multiple outlets for additional information, which I'm going to discuss further in the next couple of slides. Having an adaptive approach, accepting and incorporating feedback, and a willingness to course correct along the way as appropriate, and then transparency. So first, collaborative communication and the public outreach portion. There have been 4 community fact sheets distributed for this project, each one updated based on new information. For some sites, a community fact sheet is all you will need to do. However, for this project, additional public outreach has been necessary. There have been 5 public meetings, and I'm going to discuss more on that in the next slide. A LIRIS list, which is the water board's email notification list, is a way for the public to sign up to get email notifications for things like when the next public event will occur. That was scheduled for a couple weeks ago, but it did have to be canceled due to the COVID-19 pandemic. We also have GeoTracker, which is the water board state database for uploading reports and other information for the project. The water board has a site-specific webpage for this project, And the responsible party set up a site-specific website as well as an 800 number for any interested community members to call into or to visit to get information. And then there is a local information repository at the library. Planning for these public meetings is crucial for its success. We have followed the 90-10 rule, which is 90% preparation, 10% execution. Understanding the public's key concerns and establishing key message points. Also discussing any potential questions, especially the difficult ones, and then providing handouts as necessary, as well as involving the right people. Now, for this project, the right people include water board staff, staff from the consultant for this project, and a toxicologist from the Office of Environmental Health Hazard Assessment, or OEHA. And OEHA is our sister agency, who is the lead state agency for assessment of health risks posed by environmental contaminants. The water board is able to get assistance from them on health risk items. So for this case, we have a toxicologist to assist with addressing any health risk concerns, which has been key in preparing handouts and preparing for those potentially difficult questions, whether it's a health risk question or questions pertaining to someone's health problems, and them asking if it's because they live in the area. So here's a few of the handouts that we have prepared for this project. We developed a TCE and indoor air fact sheet, a vapor intrusion frequently asked questions, and a how to interpret your indoor air results. As I mentioned, there are 281 homes that have been sampled, and this flow chart is helping them to just interpret the results that they have received. And then presenting the information at the community meetings can be challenging, and there have been lessons learned along the way. It is really important to utilize public participation or communication specialists. Now, this ensures technical information is presented in a way that the general public will understand. It is important to understand your audience, to utilize visuals as appropriate and recap those key points, and ensure established key message items are adequately addressed. And then finally, the answering questions portion of the community meetings. Utilizing subject matter experts is key, and having them involved from the start. It is vital to discuss the hard questions ahead of time so everyone is prepared. For this project, there have been two types of hard questions, and we discuss those hard questions ahead of time and often. So the first hard question that we were anticipated were going to be health-related questions. So having a toxicologist from OEHA familiar with the site's COCs has allowed her to adequately address questions from the public. For example, we had a gentleman at one of our meetings stand up and ask in a room of over 100 people if the brain tumor his, I believe, 2-year-old granddaughter was recently diagnosed with had anything to do with living in the area, since she spends a lot of time at their home. And the toxicologist from OEHA was able to adequately answer that question, which provided additional trust from the community in our responses and our answers that we gave them. And then another hard question is regarding property value. This is an affluent community, and the responsible party doesn't have a satisfactory answer for the public regarding property value. So we've had to ensure it is addressed still in a way that doesn't derail the meetings. And the preparation of these potential hard questions has really kept the Q&A sessions successful. And then it's also important to follow up on questions that cannot be answered during the meeting. And it can be a simple question. I had a gentleman after a meeting who had his indoor air sampled, and it was not he had detections in indoor air, but it did not appear to be from vapor intrusion. It was high PCE levels in the master bedroom, and he had clothes that do get regularly dry cleaned. And it was a simple, how long should he air it out, his clothes out, prior to bringing him home? And I knew there was an answer, I just didn't have it. There were recommendations from a study, and so I didn't have it in front of me. So simply just taking down his information and getting back to him a couple days later has established good rapport with the public. And then another key component for the success of this investigation is maintaining an adaptive approach, accepting and incorporating feedback. It was necessary to modify the public outreach. For example, our first public meeting was an open house style event with multiple information stations for the public to interact with. Typically, this is a great option. However, they did not like it. They were expecting and wanting a presentation, and they wanted to know what questions others were asking. Therefore, we quickly coordinated another public meeting, which included a 25-minute presentation followed by an hour-and-a-half Q&A session. And we also learned along the way that utilizing figures within the presentation did not convey the information we hoped it would. It created confusion. Therefore, we presented figures on poster boards at the back of the room and offered to discuss them one-on-one after the meeting. And this approach has been incredibly successful. Then the willingness to course correct along the way, revising the investigation approach, such as adding sewer gas sampling as an additional line of evidence for select areas, or modifying the probe construction. So here's just a couple of photos of the sewer gas sampling that was conducted in a few select areas. It was fairly straightforward. Of course, this is coming from the regulator standing by observing them. However, I do know that the consultant did do a lot of planning and prep work to ensure the ease and success of the sewer gas sampling. And then the final key component for the success of this investigation has been transparency. And here's just a couple of examples. The ESLs were updated over the course of this investigation. And one of the ESLs happened to have been updated 1 month prior to one of our community meetings. So in order to maintain that transparency, it was discussed. We discussed that update during the presentation and what the path forward was going to be for the project at that meeting. Now, since this investigation began in 2018 and everything was designed around the 2016 ESLs, and we are still utilizing those ESLs as our initial screening levels at this time. However, as I mentioned, we do want the soil gas plume delineated to non-detect. So that way, once the indoor air results come in, it can be evaluated to determine if it is necessary to step out and include additional buildings for vapor intrusion investigation if necessary. And I mentioned earlier that the work is being done in a phased approach, and this includes the sampling of buildings, starting where the soil gas concentrations are the highest. So it was the appropriate path forward for the project at that time. Now, with the help of the DTSC attenuation factor study and a just preliminary look at this data, and looking at 723 paired data points, which is only data with TCE detections in indoor air, we're looking at an attenuation factor for this project of roughly 0.001, which is protective to the 95th percentile for current risk. Now, the path forward for the project and evaluating future risk is going to be based on several factors, and that includes the US EPA's recommended attenuation factor of 0.03, and it will also include evaluating the trend of the soil gas plume. And then finally, answering those hard questions. By not avoiding those hard questions and answering them directly, you are going to be able to gain the public's trust, because really, without their trust, in what we are doing, the entire project would go completely sideways. So now I'm going to hand it over to Tom with land science.
Thank you, Jessica. Well, I wanted to spend some time today talking about our division, land science, a division of Regenesis, and also some of the vapor barrier products that we're offering across the nation. If you're not familiar with land science is recognized as an industry leader and always at the forefront of vapor intrusion mitigation. Regenesis and land science have a combined experience in vapor mitigation and environmental remediation at more than 26,000 sites in over 27 countries globally. This visibility into many different sites gives us a unique role in working collaboratively with engineering firms and regulating bodies to make sure that we're evaluating the vapor intrusion component in its totality. As I said, we were going to talk briefly about some of the products that we offer. Land Science offers subslab vapor barriers such as GeoSeal, TerraShield, NitroSeal, and MonoShield, and also vapor barrier coatings such as RetroCoat. First, I want to get into GeoSeal. GeoSeal we have launched more than 12 years ago, and we have over 18 million square feet of this subslab barrier has been installed within the United States. It was the first of its kind, a unique opportunity where we blended HDPE with a spray applied asphalt latex. It brought the best of both worlds. HDPE is very chemically resistant, and then you have the durability of the HDPE as well. And then you also get the opportunity of the constructability of adding that asphalt latex. Combining that, as you can see here, we had a diffusion coefficient 685 times lower diffusivity than just a general asphalt latex barrier. RetroCoat is another barrier, as I mentioned, it's a coating barrier that we have offered for the past 8 years now, and we have had many successful sites, including regulatory offices that have actually installed it at their office. It's highly chemically resistant. It contains no VOCs. We actually have some sites where they can actually drive forklifts on it, so it's very strong. It can hold up to durable traffic. Multiple regulatory approvals, including here in California, with all the different agencies. And the great thing is, we can even meet a certain feng shui if necessary, and change colors, add paint chips, so it can have a decor look to it as well. Now, we also last year launched 3 new subslab vapor barriers: TerraShield, NitroSeal, and MonoShield. TerraShield is unparalleled chemical resistance. We have a dual metallized barrier film that allows the opportunity for those vapors to not penetrate through at even a more aggressive rate. So we have an order of magnitude more protection with the use of TerraShield. We also then blend in a nitrile modified core. So our GeoSeal had a latex. We modified our core with the new barriers that we've launched and added a nitrile component. So think of nitrile gloves versus latex gloves. We also offer NitroSeal now, which is very similar to our GeoSeal. However, the difference there is, as you can see there, is we have a nitra base. So the base is a bit different, still similar in the HDPE process, and then also a nitra core. So what this does is, because the nitra core has even more chemical resistance, we can lessen that thickness. GeoSeal will be sprayed at 60 mils, where NitroSeal can be sprayed at 40 mils. And last, MonoShield. So MonoShield gives us an opportunity to combat some of the situations where we face large warehouses. That is a vapor intrusion component, or vapor intrusion concern, I should say, that what you're faced with is you have large areas that have to be protected. And at some points, a 3-layered system is not really going to be the most cost-effective or constructability. So what we've offered here is a single layer system. It's a 30 mil. It also has the metallized film, as you can see here in the picture. And instead of spraying the core over the entire barrier, what we're doing is spraying the seams at a 60 mil spray with a 6-inch overlap. You can also see here we have independent third-party testing for this barrier as well, and benzene diffusivity at 2.55 at 10 to the minus 15. Significant protection. We've already installed in just a year almost 5 million square feet of MonoShield already. And last, I just wanted to briefly talk about is that Land Science not only because we offer the barriers, but we are so confident in our barriers that we can offer various warranties for our barriers. So if there's ever a question, I encourage you to reach out to us or reach out to one of our managers or engineers and inquire about what type of warranty we could possibly offer. And with that, I will end my discussion. Thank you, Dane.
All right, thank you very much, Tom. That concludes the formal section of our presentation. So at this point, we'd like to shift into the question and answer portion of the webcast. Before we do this, just a couple of quick reminders. First, you will receive an email with a brief survey. We really appreciate your feedback, so please take a minute to let us know how we did. Also, after the webinar, you will receive a link to the recording as soon as it is available. All right, so let's circle back to the questions. If we are unable to get to your questions today, someone will make an effort to follow up with you after the webinar. All right, so let's see here. Here is a question for Jessica. And Jessica, the question is, was OEHA involved in evaluating the assessment work plan or only as technical support?
Okay, thank you for that question. OEHA was not involved in evaluating the assessment work plan. However, they are involved with the risk assessment reports, and they are currently providing feedback regarding the approach for preparing the risk assessment reports, including how the existing data is going to be used and any assumptions that are going to go into the risk assessments. And OEHA will be involved with the review of the risk assessment reports as well.
All right, thanks. So Jessica, here is another question for you. And it is, of the 281 homes sampled, how many homes demonstrated vapor intrusion, and has any mitigation been performed yet?
Yeah, so of the 281 homes that have been sampled, there's about 25 homes or so that have exceedances of indoor air screening levels that do appear to be vapor intrusion. Now, of those 25 homes that had exceedances of the long-term screening levels, 4 of those homes had exceedances over the short-term exposure risk numbers. And as far as mitigation, air purifiers were immediately offered for any homes with exceedances over those short-term action levels. And the air purifiers were deployed when they picked up the confirmation indoor air samples. And then also, due to the length of this investigation, we have requested short-term mitigation measures to be offered to homes that have exceedances of those long-term ESLs as well, while a soil vapor extraction pilot test is being conducted and evaluated, as well as those risk assessment reports being prepared to assist with determining what the next steps are for the project.
Okay, great. Thank you so much, Jessica. So here is a question for Tom. And the question is regarding retrocoat. Can retrocoat be installed by itself, or does it need to be installed with venting?
Well, that's a great question. It depends on the site we're dealing with. And the regulatory agency that we're working with. There are sites that we can recommend that retrocoat itself will be most protective. However, if the opportunity is presented that we can add a venting, whether they're doing utility trenching and they already have the opportunity of cutting the concrete, we can work with the engineer and consultant to identify if venting will be required and or would be best. But retrocoat can be a standalone barrier.
Okay, thanks, Tom. Jessica, here's another question for you. And the question is there any direct spatial correspondence of the groundwater plume and soil vapor plume? And if the vapor drifted to some extent away from the ground plume, if so, what was the identified preferential flow at that site?
So really, it depends. The groundwater plume from the main area, that flows towards the north, and it follows one of the buried arroyos up there. And that main large soil gas plume does mostly go in that direction as well. But there is that portion of the plume that is migrated away from it towards the east, and that does not follow any of the known hydrology or groundwater flow direction for that area. And it's located between buried arroyos, so maybe that would be the preferential pathway, not sure with that. Then the southern groundwater plume does not have an associated soil gas plume with it, and that southern soil gas plume really was not expected. So because of that, we're currently getting ready to do some additional assessment in that area to get more information. You know, is there an unidentified source? Does groundwater travel in an additional direction that was previously not identified? So we're really seeing a combination of it following both the groundwater plume and then potentially not as well. So, you know, we're just needing to get some more information. So there's no easy, I guess, rule of thumb and assumptions that can be followed for this project.
Okay, thank you, Jessica. So Tom, here's another question for you. You mentioned warranties. Does Land Science offer a warranty for all of your vapor barrier products?
As I briefly mentioned, we do offer warranties for all of our barriers. It all depends on the site, so what we encourage is that the consultant or developer, whoever is starting to engage us, that they work with us and give us as much information from site data to building construction, so we can look through and see what type of offer we can offer with our barrier and the warranty. Sometimes it can be a system warranty where we then offer 20 and 30-year warranties for the barrier itself. That would require, I should say, having a third-party inspector. But again, what I encourage is that if that question comes up, it should come up early and get in touch with us so that we can evaluate what type of warranty we can offer. But we do offer warranties for every one of our barriers.
All right, thank you very much, Tom. So, some more questions here. Jessica, this is a question for you. Do you have any soil sampling? And if so, what is their correlation between soil and soil gas results?
So for this project, there's not been soil sampling at this time, since most of these probes are placed off-site where we would not expect to have a soil source. Also, the on-site source areas were remediated in the 90s. However, there's going to be some additional assessment that's going to be conducted in select areas. So there will be some soil sampling conducted to see if there is a correlation, but right now we just don't have that data to support it. But it does not appear that there is a soil to soil gas correlation.
Okay, thank you. And so here is another question for Jessica. And the question is groundwater tidally influenced? And if so, do you see any differences in vapor concentrations with the tidal changes?
Yeah, for this site, since we're 2 miles inland from the Pacific Ocean, we're not seeing any kind of tidal influence. And the groundwater flow directions have really, as well as the contaminant plumes, have really been consistent for this project. Groundwater leaving the main area does flow towards the north, and from that ATC area, it flows towards the south-southwest. And then as far as the soil gas plume and those few soil sampling events that have occurred, they really have been pretty consistent, and we're not seeing a fluctuation one direction or another.
All right, thanks very much, Jessica. That is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you'd like to learn more about vapor intrusion solutions from Land Science, please visit landsciencetech.com. Thanks again very much to our presenters, Jessica Law and Tom Szocinski. And thanks to everyone who could join us. Have a great day.